Hello, let's model this part in Creo parametric. Yeah, might be simple, but I'm going to illustrate some of very important techniques used here. Let me start a new part. This one I'm going to start from scratch. And as I said in my previous videos, it's a good idea. Always make sure that you have the boundary. Therefore, let's go here. On the top plane, let me first sketch a center rectangle. This one is going to represent the external boundary like that, and this one is the boundary. Use of boundaries is very important to make your models more stable and robust. Call this one to be boundary profile. Then our profile will be on this like that. Then we can now create circular profile. Just see, I just reference this and this. Then I just need a 3-point circle. First point, second point, third point. I don't need to dimension this. Yeah. Or let me just use the center circle, center point, like that. Because I don't need to dimension it. I'm referencing my boundary. This one represents the top profile. Let me call it circular profile, like that. Then let me activate my planes because I want to sketch the height profile here, like that. Here I'm going to use corner rectangle. If I go view like this, and let me hide planes. I want to reference my boundary like that. This is the power of boundary to make your models parametric. Therefore, like that, I just need to dimension just height. And now all the dimensions that are bounding box of my design are done, because you need length, width, and height. Then I need to model the central section here. That is let me just go to shaded with edge. This surface. Now we're going to model this surface first. Therefore, I'm going to use a revolve onto this plane, and I need to hide my planes. I'm going to snap at this line here, and okay, yeah. Then I need to select an arc from this point here, center, like that. I just need to define one total length from this point to this point, 65, and diameter like that. Done. Axis, I need to create an axis here. I can do an axis on the fly. Let me see if that's possible. Front. Okay, let me first create a point here and a new point here, like that. Then I can do an axis between those 2 points. Let me show the points here between this point and this point. I can do an axis like that, which becomes my I have to use it as my revolve axis. Oh, okay. Okay, let me just go back here, pause, and go back to redefine my axis. Let me define my point again. Yeah, I selected wrong edge. I was to select this one here. I'm using 0.5 to ensure that these are the middle. Then I can now create my axis between that point and that point. Okay, then I can use it as a revolve axis like that. And I don't need this one, delete. Yeah, this point I don't need it. Go here, edit, and this point delete it. Yeah, that's how you create a revolve, and we can create datums on fly. On fly means as you create your feature. Next, I need to create some curves. Let me show you. Therefore, you need to create this curve, this line, and this line, then this curve. That's my next thing. Then we are going to blend these two surfaces. Okay, therefore on top, sketch on top, and let me use a line from this point to that point, and we can select this one here, mirror to this, and this has to be 60. Done. Again, this one is called, you can call it V shape. Again on top, let's create the wavy shape from this point to this point, and let's dimension this point, and this line to be 90. This point line to be 90 to be wavy. Yeah, and this one here we can give it around 100 or 120. Let's go with the 120. 115 was okay. Okay, like that. We have now this profile and this. Therefore, since we need to blend this to this, what does it mean? We need to connect this curve. We need to project this curve to this surface first. Then let's first of all do that. Project. Before you select project, it's a good idea. I said always select this one here, project, so that they can fill for you the direction here, like that. Therefore, we have projected our curve. Since we want to connect this to this, we need a datum on this one here, a datum that will allow us to maybe define tangency or whatever the continuity we want to define. Therefore, I'm going to create a sweep surface here first. I'm going to sweep, and I'm going to sweep normal to projection, top direction, and I can use variable or constant, whatever, both can work, and do a sketch. Therefore, remember this is my line, and I'm projecting normal to this. When I say normal to projection, let me illustrate. This is the top plane here. This is the top plane, and I'm saying normal to projection. Therefore, the direction of this will always be the direction of as you go, as you sweep around the path, the profile will always stay normal, the cross section. Therefore, this cross section here will always be stay normal to the to the to the plane. Therefore, understand that normal to projection means the cross section will always stay normal to the actual plane. And here I want this angle to be 5 and this height to be 10. I think I'll make another video to illustrate in a proper way difference between normal projection and normal trajectory. It will make sense when I use an actual video. Yeah. Therefore, like that. Yeah. Then say okay. Therefore, you have this surface, our datum surface, and the purpose of datum surface is or to ensure you have a surface that you can use to define continuity and a surface that you can use to define draft angle. The value I used here, this value is a draft angle, because in surface in plastic design or most of the designs you must have a draft angle. Next is I need to connect this point to this point with using a datum curve, but there's something very important here I want to mention, and you'll see what I mean later. That remember this model here, you model these two, then you pattern. We're going to do the same thing here. First, I'm going to do the in a normal way. I'm going to create my curve here, curve through points from this point to this point, like that, and this point to be tangent to this face here, to this line. This point I'm going to leave it like that for now. I'll come back there from this point to this point, this to be tangent to that. Yeah, change direction. Okay, therefore now I can easily use blend this to this, and second direction I can easily use this and this, and here I can say tangent, yeah, like that, like that. Let me first illustrate the first issue. If I try to say this point to be tangent, you see the preview disappears. If you try to preview surface, we can see there's an error. Let's see the error saying bounding curves are not tangent to tangent surface at highlighted points. You'll see this point is highlighted. You can see this point here, and it's saying what it means is this curve is not tangent to this curve here. Hence, we can never use as tangency. Recommended actions: leave tangency conditions or redefine the curve. Okay, let's continue. We can't use tangency because we don't have tangent here and we don't have tangent continuity. Therefore, here we can't use tangent continuity. Therefore, use free for now. Let's fix that issue. Go back to my curve. You edit your curve and use tangent and select this edge, this face. Again, the other curve, you go to the other curve, right click here, select tangency to this face. If now I go back to my boundary, if I try to define this being tangent, we are still losing it. Why? Let's see. Let's go to here, item 1, bounding curves are not tangent to the surface at highlighted points. Okay, let's see what is happening here. It's good to troubleshoot. Okay, if I go back here, what is this? This one, let's now reselect the items you used here. I'm going to use edge option. Edge. Now select edge. Now select this and this. I'm using edge option now. Go back to tangent. Now it is okay. You might ask what has happened. When I selected initially boundary, remember we have this sweep and we have this sketch tool. When you select boundary, do not use sketch because you can easily select sketch. Okay, you have to use, to be sure you are using the edge of a surface, it's good for you to use an edge option here to make sure you are selecting an edge, not a sketch, because we said this will be tangent to the surface to which the edge belongs. That's very important for you to understand that. Okay, let's now, we don't need this anymore. Let me hide, let me go back to geometry, hide this, we don't need it. Let's now select this one here and pattern it using axis, the one used here, angular extent 6 pieces. It's okay. Let me first hide all of this because there's some very important thing onto some important tips I want to discuss with you. You might think the design is ready when you see something like that. Let me hide these curves here because I don't need them, but not yet. If you go to analysis, let me first of all, if you go to analysis, let me just use this. There's what we call a dihedral-angle. Dihedral-angle is very important, is one of the analysis you need to perform whenever you circular pattern your surface designs. When you mirror them, it's good to perform the dihedral analysis. The dihedral analysis defines the angle between two surfaces. Let me use an example first here for you to understand what I mean. If I was to create a surface here, let me create a surface here using let me just align here like that. Let me extrude up to 100. Another one here. Now I want to let me hide these surfaces here. I want to sweep a surface onto this edge. I want to use this as an example for you to understand the dihedral. Yeah, let me use a sketch there. Let me see. Yeah, let me sketch like that. Then yeah, I want to measure. I want this to be 50 and this to be 45. Okay, this angle here, I want this angle to have 45, this angle to vary. For me to make this angle vary, I can go to relations here. Let me make this angle to vary. Let me say equals, I want it to be 45 multiplied by charge per. I want minimum to be 10. Let's use minimum to be 15, maximum to be 45. Okay? Yeah, okay, let's do that. Okay. Now if I go back to my sketch, you can see my profile surface is having a constant. You can see it's having a constant angle. Let me go back here to illustrate why. When you have to use variable, we have to select variable here for my profile to vary. You can see we said start from 45 to 15. Therefore, the angle between these two at this point it is 45. The angle between these two edges at this point is 45, but these two here is 15. You can measure these two angle minimum and maximum. This is a minimum, this is a maximum using the dihedral analysis. It gives you the angle between two surfaces that meet at one edge. The angle between this surface and this surface at this edge. But you see we have the angle is not constant. Okay, if you perform the dihedral angle of this edge here, you'll see, as you said, minimum we said 15, maximum was 45 plus 15. You can see because at this point we have 60. Here we have minimum 15 because I defined this angle here. When I went to the sketch, I went to the tools, relations here, I said 45 plus 15. Transfer is a function that returns 0 to 1. When it returned to 1, we got 45 plus 15 to get 60. Therefore, we use the dihedral analysis to determine the angle between two surfaces. If I go back to our design now, let's do again the same thing here. Dihedral analysis. I'm determining the angle between, it returns the angle between this surface and this surface. And I can see we are getting 0 here because why? We had defined tangency here, but here I'm getting 0.74, meaning this surface and this surface is not tangent. We need to get 0. 0 means it is tangent. Okay, how can I now fix that? I have to go back. I have to go back here and go back here before creating the curve. And this V shaped, I've shown them, all of them. Therefore, remember how we did this border here, this one here, we said free. But when you try to do a tangent, it will fail because it doesn't have anything to be tangent to. You see? Therefore, basically, we need to fix this point. We need to fix this point to be tangent and this point to be tangent such that when you pattern and get a new surface, this side will have a smooth continuous here to be continuous. Something else we can do, let me first focus on this and go to what we call curvature. Not curvature, let's do diffraction of this surface. You see, we don't have, you see, once we start to zoom in, you can see we don't have smooth or transition between the surface to the surface. That's what we need to fix. Therefore, I'll go back here and I need to activate my planes. This is how you fix it. You select this plane. I need a plane here. I need a plane onto this edge and this one here, and to the top it will be normal like that. A plane below there. Again here, let me do another plane, this edge and this here, but the top will be normal like that. Have those two planes. If I go back to my first curve, I can redefine my curve and I want to place this curve onto this plane. Place the curve onto this plane and interchange like that. Therefore, I'm sure this curve lies onto this plane. Again, you go to the next curve, edit here, place this curve onto this plane like that. Now I'm sure if I try to create tangency, it will be possible because now I have something to which the curve can be tangent to. If I now select normal, you can see now it can be normal. You can be normal. Normal means, what does the normal mean? Normal means this. We have a plane and we're going to create a surface here. This surface will always be normal to this. It will always form 90. Therefore, if I try to mirror or circular pattern this surface, it will leave at 90, and this will be tangent. These two surfaces will be tangent to each other. Therefore, let's now see. Let's go back to analysis. Let's first of all do what we call refraction of this and this. You can see now our surfaces, they are connecting in a very nice way, except this side. But you can see here these two surfaces are connecting in a good way. Yeah, we can still as well fix this if you want. Yeah, let's do some dihedral angle of this edge. Now you can see we are getting 0.0. This one is the tolerance. of the software, but you see this one is acceptable. It is almost zero, meaning these two surfaces are tangent to each other. And now you can go back to a model. You can merge. When you merge, make sure you select, don't select random, make sure you select one by one. Then you thicken maybe by 1, and that's the design. You can see now, you can see this has sharp because we don't have tangency continuous there. Yeah, I hope you have learned something in this small session. In surface modeling, that's how you learn to design bigger things, by understanding the basic fundamentals principles of surface design. Thank you, and let's meet in my next video.